For today's lesson, we're going to talk about factoring polynomials. Now, we're first going to talk about the sum and difference of cubes. Now, if you remember, we talked about the difference of squares in one of our earlier units. Now, what this looks like is we have something cubed plus something cubed, or a to the third minus b to the third. So our difference is when we're subtracting, and our sum is when we're adding. All right, now what happens is we're going to get these a and b terms. Now the a and b terms are what we get when we take like the cubed root of that first term and that second term. So what's going to end up happening is we're going to get an a and a b value, and our formula that we're going to plug this into after is a plus b, and then we have a squared minus ab plus b squared. So that's kind of the format of how we will factor a sum of two cubes. Now the difference of two cubes is very, very similar, except here we have the a minus b, and then in the second set of parentheses, we have a squared plus ab plus b squared. All right, so we're going to use these formulas. And then lastly, sometimes we just won't be able to factor a polynomial. It just won't be able to be factored, and that we call prime. So if we couldn't factor something, we'd just write prime underneath it. All right, so let's look at these problems here. So we're going to take a look to get our a and our b. We want to think about like taking the cubed root of each of these. All right, now here with this first problem, we do have a difference because we have a minus in the middle. So just keep that in mind. You have to pay attention to those signs. So if I take the cubed root of x cubed, that would kind of cancel out the cubed part, so we'd just be left with x. So our a would be x here. Now if we go to take the cubed root of 400, that actually comes out to something that's not going to work out well for us. So something like 7.36. Now, since that's the case, it doesn't come out to a perfect number that we're looking at. This would be an example of a prime answer. Okay, so this problem would be prime because we can't factor it nicely. All right, let's look at this next problem. So again, to get our a and our b, we want to look and think about taking the cubed root of each of these pieces. So whatever's in that first spot becomes the a, whatever's in that second spot is our b. So if we take the cubed root of 8, that will give us 2. So I'm just going to write this out so you see where I'm getting this. So the cubed root of 8 will give us 2. So that'll be the first part of our a, but we still have that x to the third. Remember, the cubed root of x to the third is just going to give us x. So our a term would be 2x. Our b term will come from taking the cubed root of 64. And that's going to give us 4. All right, so there's our a and our b term. Now we have a sum here because we have that plus in the middle. So that means that we're using this formula right here. I'll write it down here. We have a plus b times a squared minus ab plus b squared. All right, now our a is 2x and our b is 4. So wherever we see an a, we're putting a 2x. Wherever we see a b, we're putting a 4. So I have a plus b, so 2x plus 4. And then my second set, I have a squared. So I have 2x, and I'm going to square that. So if I square that, remember the 2 gets squared and the x gets squared. So I have 4x squared. And then the next part is minus, we're going to do a times b. So that's 2x times 4. So that'll give me 8x. Plus b squared, well, 4 squared is 16. And that would be my factored answer. I know it looks kind of crazy, but that's what we'd get. So if we were actually going to distribute all of this back through, do all the multiplication out, we would end up back at 8x to the third plus 64. All right, I'm going to change this last problem. So I want to write this as v to the third minus 125w to the third. Okay, so the first thing we want to do again is try to establish our a and our b. So we do that by thinking about taking the cubed root of both of these terms. So v to the third, if I take the cubed root of that, I get v. And then 125w to the third. So I'm thinking about taking the cubed root of 125, which will give me 5. And then I'm also taking the cubed root of w to the third, which just gives me w. So my a term is v, my b term is 5w. Now we have a difference here because we have that minus in the middle. So our formula in this case is a minus b times a squared plus ab plus b squared. All right, so let's take our a minus b. So again, our a in this case is v. So we have v minus 5w, which is our b. And then we have a squared, so it's just v squared, plus a times b. So we have v times 5w. Well, v and w are not the same variable, so can't square any of them. So I'm just going to write them all next to each other. 5w and then plus b squared. So again, our b is 5w, so we're squaring each piece of this. All right, so that gives us 5 to the second, which is 25, and w to the second. So 25w to the second. And this will be our factored answer. All right, now this page here just lays out a bunch of the factoring things that we've talked about and what we're going to be working on today. So previously when we talked about our quadratics unit, we talked about greatest common factor. We also talked about factoring trinomials. And so that's these cases right here. So this is factoring a trinomial. So remember, you're trying to find the two things that add up to the middle number and multiply to the last number, so the b and the c term. We have greatest common factor here. And we also talked about the difference of squares, which is this case here. In the last slide, we talked about the difference and sum of cubes. So that's those two problems, those two formulas. And then lastly, we're going to be talking about cases where we have 4 terms. All right, so this is different than what we've been talking about so far. So difference of cubes, difference of squares, sum of cubes, those all had 2 terms in them. All right, so that's why they're all categorized together. And then the trinomials had 3 terms in them because they are trinomials. That means they have 3 terms. We also talked about the trinomials having them being a quadratic, so to the second power, second degree. But this last case that we're going to be talking about is a group. We call it grouping. So we have 4 terms, and we're going to group the first 2 and the second 2, and then do a greatest common factor kind of thing. Now, we did a very similar process to this when we were factoring our trinomials when a was greater than 1. So hopefully this kind of process will seem pretty familiar. So let's look at this first problem here. All right. So we're going to group these. So I'm going to put the first two together and the second two together. And I'm going to take the greatest common factor out of each set of parentheses. So I have x to the third plus 2x to the second. So I can't factor out a number because I have a 1 and a 2, so that's already as simple as that can get. But I have x to the third and x to the second. So I can factor out 2 x's out of each term in that set of parentheses. Now what that leaves me with is x plus 2. All right, so again, I just factored out the greatest common factor out of the first set of parentheses. Now the second piece, I'm going to do the same thing. So with 8 and 16, I can factor out an 8 out of both of those. They both don't have an x term, so I can't do anything with that. So I'm just going to leave that as x plus 2. So again, that's after I factored out that 8. Now, again, what you should see here, you should see that this and this are identical. All right, so that's one part of our answer. So we have x plus 2 as part of our answer. And then the other part of our answer are these two terms together, x squared plus 8. All right, and that would be our factored answer. All right, we're going to do the same thing here. So again, we're grouping first two, then the second two, and then greatest common factor. All right, so I can factor out of this an x squared, leaving me with x minus 2. All right, and out of the second set of parentheses, I can factor out a 4, leaving me in the parentheses with x minus 2 again. Now again, we want these to be identical, so that's one of our factored terms. All right, and then these are going to go together in our next set of parentheses, x squared plus 4. Now, it really doesn't matter which order you write the parentheses in. I could write this as x squared plus 4 times x minus 2, and that would be the same answer. When you're multiplying, the order does not matter. So I would accept the answer either way. All right, so we're just going to go through a few of these. Again, very similar process to what we've done before. So I'm going to start by grouping. Out of this first set of parentheses, I see I can factor out both an 8 and an r squared. So that'll leave me with just r for that first term minus 8. All right, so again, I'm dividing out the 8 and the r squared from each of the terms in that set of parentheses. So I'm factoring out the greatest common factor. Now in the next set of parentheses, r minus 8, I cannot factor anything out. But I can, if that's the case, I can factor out a 1. So I'm going to leave that r minus 8. And when I do this, what happens is that if I go to multiply that 1 back through, it's not going to change anything. It still leaves me at the r minus 8, which is what I need for those to match up. And then those are going to go in a set of parentheses together. So I have 8r squared plus 1, and it's plus 1 because it's a positive 1, and then r minus 8. All right, at this point, it might be good to pause the video, try a couple problems, and then play the video to see if you are getting the correct answers. So do a couple on your own. So I'm going to do problems 2, 3, and 4. All right, so I'm going to factor out a 3p squared out of each of these terms. And that leaves me with 4p minus 7. All right, and then here I'm going to factor out a 7, and that leaves me with 4p minus 7 again. So these are going to go together. So I have 3p squared plus 7, and then 4p minus 7. All right, number 3. Again, I'm going to throw my parentheses in there. All right, so I can factor out a 2x squared out of each of the terms in the first set. So that leaves me with 6x plus 1 because I need a placeholder there, okay? Because when I go to multiply this 2x squared back through, if I go to distribute that, I should end up right back where I started. So remember that factoring is the opposite of distributing, or the opposite of multiplying. Now with the second set here, see how both the 30x and the 5 are negative. So if they're both negative, I'm going to factor out that negative with it. So in doing that, I'm going to end up with, I'm going to factor out a 5, negative 5. So I'm left with a 6x because negative 30x divided by negative 5, that negative over a negative, those are going to turn into a positive. So that'll leave us with the 6x. All right, and then plus 1, because again, negative 5 divided by negative 5 will give us 1. And why we want to make sure we factor out that negative is because we want these two sets of parentheses to be completely identical. So we want the signs to be the same as well, which they are when we factor out that negative. So our answer is 2x squared minus 5 and 6x plus 1. All right, and lastly, number 4. With that first set, I can factor out a 2v to the second, leaving me with 3v minus 8. And then the second set, I can factor out, let's see, a 7. So that'll leave me with, again, 3v minus 8. So my final answer is going to be 2v squared plus 7 times 3v minus 8. All right, so this last piece we're going to talk about is an expression that's in quadratic form. So I want you to think back about when we were factoring quadratics. So we're trying to find two numbers that add up to the middle and multiply to the end. So let's start there. All right, I'm going to throw my x's in here. We're trying to find two numbers that add up to 5 and multiply to negative 24. So I'm going to list out my factors. So I have 1 and 24. I have 2 and 12, 3 and 8. Now, what we're looking at is we're multiplying to a negative number. So remember, that means one sign has to be negative. But since the number we add to is positive, we know that bigger number is going to be the positive number. So I'm going to throw my negatives on my smaller numbers. And I see that the combination that works is a negative 3 and a positive 8. Now, if you go to FOIL this out, we're going to end up with x squared plus 5x minus 24. Now, it's super close to what we're looking for, but not exactly it. So what we have to do is we have to make this x to the third. Because when we want to FOIL that, when we want to multiply that back through, we want that first term to be x to the 6th, okay? And I'm just going to show you if we FOIL how it's going to work out. So x to the 6th, because remember we add the exponents when we multiply. Outside we'd get plus 8x to the third. Inside minus 3x to the third. And last is negative 24. Now, again, why we're trying to find two numbers that multiply to that negative 24 is because when we do that last piece, we're multiplying negative 24. Then when we combine our like terms here, we're adding two numbers together to get that positive 5. So we'd end up with x to the 6th plus 5x to the third minus 24. All right, so you really have to look at your exponents here. So I see that if I took my 3 and my 3, those are my first exponents of each of my terms, and I add those together when I do FOIL, it's going to give me that x to the 6th. All right, and then when I still do my regular combining, it's going to give me that x to the third. All right, so this would be our factored form here. This would be our answer. So let's look at these next few problems and see what we can do to solve these. All right, so I see I have x to the 4th and x to the 2nd. So what that tells me is I know I need to have x squared as my first term in each of my sets of parentheses, because when I do x squared times x squared, I'll get x to the fourth, and then when I'm doing my other multiplication, I'll have that x to the second still. So we're looking for two numbers that multiply to 1 and add up to 2. Well, that would be 1 plus 1. So I have plus 1, and that's my factored form. Now you could also write this as x squared plus 1 squared. All right, so with this next problem, we have x to the fourth minus 2x to the third minus 1. Now, because we don't have the same kind of thing happening with our exponents, this is not going to work. So there's no combination that we're working with here, that if I had x to the second times something with x to the second, yeah, sure, that'll give me x to the fourth. But when I go to do my multiplication here, I'm going to do something that'll give me an x to the second term and an x to the second term. So because these don't work well together, basically what you want to see is that you have a 6 and a 3. So 6 divided by 2 will give you that 3. 4 divided by 2 will give you the 2. Things like that. This doesn't work out, so this is prime. All right, and again, it's because of these exponents. There's no combination that we could work with in this fashion that'll make that work. All right, let's look at this next problem here. So again, we have x to the fourth. So that will tell me that I have an x squared and an x squared because, again, we're combining to get an x squared term for our b term. And I'm looking for two numbers that multiply to 100 and add up to 20. All right, so the numbers that will add up to 20 and multiply to 100 are 10 and 10. So this would be my final answer here. All right, and lastly, we have x to the fourth minus 2x squared plus 1. So again, we have that x to the fourth and x to the second. So I know the first term in each set of my parentheses is going to be x squared. All right, now I'm looking for two numbers that multiply to a positive 1 and add up to a negative 2. So negative 1 times negative 1 is going to multiply to a positive 1, but then when we combine them together, we get negative 2. All right, so that would be my answer there. Now I want to give you a few more examples that aren't on the slides here, so I'm just going to write them below. So let's say we have x to the sixth minus x to the third minus 12. So again, we want to look at these exponents. So I see if I had x to the third as my first term in each set of parentheses in each of my factors, that would work well. So when I multiply those together, when I do FOIL, that'll give me x to the sixth. And then when I'm doing my outside and inside, it's also going to give me x to the third terms, so that when I combine them, I'll have that x to the third. So this will work nicely. So now I'm looking for two numbers that multiply to negative 12 and add up to a negative 1. So I know that my factors are going to be 1 and 12, 2 and 6, 3 and 4. And now I want to see that my bigger number is the negative 1, because when we combine, that b term is negative still. All right, so the combination that'll add up to a negative 1 multiplied to negative 12 is 3 and negative 4. So my final answer would be x to the third plus 3 and x to the third minus 4. All right, and let's look at one more. Let's say we have x to the sixth plus 5x to the third minus 36. All right, so I'm going to start by looking at my exponents. I know I have x to the third as my first term. And then we're going to multiply to a negative 36, add up to a positive 5. So I know that my bigger number is going to be the positive one because my b term is positive. So that will leave me with a positive 9 and a negative 4. So we have x to the third plus 9 and times x to the third minus 4.